everyone, in this video we are going to show you how geologists identify minerals using physical properties such as color, luster, streak, cleavage or fracture, hardness and reaction with acid. So in this video, I will be using sulfur as an example. These are the equipments and materials used in this experiment. So first, let's look at the most obvious one, color. Sulfur is well known for its bright yellow appearance. To confirm the exact shade, I used the Marshall rock color books, which help geologists match color accurately. The sulfur sample I test matched 55706, which fall into the yellow range, a moderate yellow. Now, let's move on to streak. Streak is the color of a mineral in powder form. To test it, I use a streak plate, which is just a piece of unglazed porcelain. When you rub a mineral across it, it leaves behind a streak of powder. With sulfur, the streak is yellow, which actually matches the surface color. Next, luster. Luster describes how a mineral surface reflects light, whether it is shiny like metal or glossy like glass. As you can see, with the light, it looks like solidified resin or even a bit waxy, especially on fresh surfaces, so sulfur has been classified as non-metallic. It's not super shiny like metal, but it does have a bit of glow when light hits its surface.
So now, let's see this sulfur mineral whether it is cleavage or fracture by looking the surface of mineral. As we can see, the surface of sulfur is irregular and uneven. This means that when sulfur is struck, it will break into uneven pieces because sulfur is a brittle mineral, meaning it's easily broken. Its crystal structure is not conducive to cleavage, and instead sulfur fractures in an irregular manner. Therefore, sulfur exhibits a fracture rather than cleavage. Now let us test the hardness of sulfur mineral by scratching the mineral using Mohs hardness pen set. I start scratching the mineral using the pen label with the lowest hardness point, which is 2. This number represents the mineral approximate hardness on the Mohs scale. After scratching, the sulfur leaves a scratch. When a scratch is made, means that the mineral's hardness is lower than the hardness point we use. So, the hardness of sulfur is around 1.5 to 2. This shows that sulfur is a soft mineral. Lastly, we want to know the reaction between sulfur mineral and acid. The acid we use is dilute hydrochloric acid. First, I added a few drops of acid into the sulfur powder that we made it by scratching the sulfur mineral before. Then we wait for a few seconds and observe whether got gas bubbles come out or not. As we can see, there's no any bubbles released, means that no product is formed. There's no reaction occur between sulfur mineral and dilute hydrochloric acid.
Doing this experiment really helped me see just how important it is to use a clear step-by-step method when identifying minerals. Minerals might seem simple at first glance, but they are the foundation of rocks and plays a big role in areas like geology, material science and environmental studies. I learned that you can't just go by how a mineral looks, since things like impurities or weathering can make appearance misleading. Instead, we need to test a range of physical properties like color, streak, luster, cleavage, hardness, and how it reacts with dilute hydrochloric acid. Each of these tests gives us a clue that brings us closer to figuring out what the mineral really is. So for example, sulfur. It's bright yellow, but so are some other minerals. So to be sure it's sulfur, we also check things like its strength, how soft is it, and whether it's react with acid. Putting all these clues together gives us a much clearer and more reliable answer. Doing this experiment didn't just teach me how to identify minerals. It also helped me practice key scientific skills like observing carefully, thinking critically, and using evidence to make decisions. In the end, this activity showed me that identifying a mineral is more than just ticking boxes. It's about using science to understand the world around us. Testing sulfur physical properties gave me a hands-on ways to see how geologists work and why their methods matter. It was a great reminder that even something as small as a mineral sample can tell a bigger story about how our planet works. And through this, I've gained useful skills I can carry into future scientific studies and a deeper appreciation for the natural materials we often take for granted. Thank you.
In this experiment, I learned how to classify minerals based on their physical properties such as color, strength, luster, hardness, cleavage, and reaction with acid. By observing and testing these characteristics, I was able to identify different mineral samples and better understand how geologists categorize them in the field and in laboratories. The experiment showed that while some properties like color can be misleading, others like strength and hardness provide more reliable identification methods. Overall, the activity deepened my understanding of mineral properties and their importance in geological study. Personally, I found this experiment very informative and hands-on. At first, I was confused about how to differentiate minerals that look very similar. But as I practiced using tools like the straight plate and Mohs hardness scale, I became more confident in my observations. I also realized the importance of using multiple tests rather than relying on just one properties. This experiment helped improve my observation and critical thinking skill, and now I appreciate how much detailed work goes into identifying something like a rock or minerals. It was a challenging but rewarding experience. Thank you.